Refraction of light through a rectangular glass block. This is our next topic. We have a PQR is a rectangular glass block. That means PQ is parallel to SR. Okay, so this is the incident ray and this is the normal. The incident ray is striking the first surface PQ, making an angle I, and it is striking at this point O. Since this is air and this is glass, so medium is different, therefore this ray gets refracted. And this is optically a rarer medium, this is optically a denser medium, therefore it will bend towards the normal. And again at this point B, this is glass and this is air. So again what will happen, it will suffer refraction, but in this case it will bend away from the normal. So this is the final ray emerging from this glass slab, and this ray we call it emergent rays. Okay, so this is what is happening over here. So here bending towards the normal, here bending away from the normal. Okay, and this dot line which is shown here, we call it direction of the incident ray. That's the original direction of the incident ray. If this glass slab were not there, then this incident ray would have been in this direction. Okay, because of this glass slab, it suffers refraction and finally it gets immersed in this direction. Okay, now let's go to some mathematical things over here. This is the angle of incidence and this is the angle of refraction. Okay, now it's striking over here and it's emerging like this. Okay, since this PQ and this SR are parallel to each other, this angle we are called alternate angle, this angle will be equal. So this angle is just like this and this angle. If this side and this side are parallel, then this side, this angle and this angle has to be equal. So this angle R and this angle R has to be equal because this PQ and R is a parallel. Understood? Very easy. Now these are alternate angle. This angle and this angle are alternate angle. This is also R, and this is the emergent ray. And this angle between this normal and the emergent ray we call it angle of emergence, which is E. Now from the principle of reversibility, this emergent ray angle of emergence and this angle of incidence has to be same. Why? Because only if this emergent angle is E, then this will be R and this will be R and this will be finally I. Okay, and as you know that the principle of reversibility is always followed, this angle of emergence has to be angle of incidence. Okay, this came because of this region, this R and R has to be equal because this PQ and R is the same. I think you understood this part. So till now we know what? We know this R and R is equal, this angle of incidence is equal to angle of emergence. If this angle of incident and this angle of incident and this angle of emergence is equal, then obviously this AO incident ray, this EC emergent ray would be parallel. This would be parallel, which is shown in the figure. Even though there's a shift over here, this is the original direction of the incident ray and this is the emergent ray. There's a shift over here, but they are parallel to each other. Okay, that's there. Why? Because this angle of emergence and this angle of incidence is same. Now this is the emergent ray and this is the direction of the incident ray, and the perpendicular distance, this distance between them, we call it lateral shift, which is given by small x. So this is the lateral shift. Okay, so now this lateral shift depends upon what factors? This depends upon three factors. Firstly, it depends on the thickness of the medium. Thickness of the medium means thickness of this glass slab. So more the thickness of the medium, more is the lateral shift. So more is the thickness of the medium, more will be this shift. Okay, secondly, it depends upon the angle of incidence also. More the angle of incidence, more is the lateral shift. Third, it depends on the refractive index. More is the refractive index of medium, more is the lateral shift. Why this happens? Because if the refractive index increases with the decrease in the wavelength. Okay, I'm sorry. More the refractive index of the medium, more is the lateral shift. And we know that the refracting index of the medium increases with the decrease in wavelength. So letter shift will be more if you use the violet, because violet has less wavelength. Okay, so letter shift will decrease if you use the violet light. Letter shift will be more. I'm sorry, I just said it wrong. More is the refractive index of the medium, more is the letter shift, and the refractive index increases with the decrease in wavelength of light. So letter shift increases with decrease in wavelength of light. No, which is very simple. So as we know, the letter shift, I'm sorry, the wavelength is more for red light than the violet light. Therefore, letter shift or letter displacement is more for violet light.